The challenge in this problem is to simplify 7 over square root of 3, you need to rationalize the denominator, and to do that, you need to multiply top and bottom by the square root of 3. And it looks like you did this part, sort of, but what you get when you do that is the top becomes 7 square root of 3, and that's what you put in for your answer. But the bottom, the square root of 3 times the square root of 3 is the square root of 3 squared, which is just 3. So you have to have a denominator of 3. The easy way to do this problem is to remember this formula. It's very important. A plus b times a minus b equals a squared minus b squared. You should have learned that formula before, only before you learned that a squared minus b squared equals a plus b times a minus b. So, if you notice that something is of the form a plus b, a minus b, then you can apply this formula, which would be, your answer would be a squared minus b squared. In this case, a is square root of 3, so you'd have square root of 3 squared minus, and b would be 6. Now the square root of 3 squared is 3, and 6 squared is 36, so that equals 33. So you see how easy this is if you know this formula. And that's really what the problem's testing you on. You could also do this problem using FOIL, but you're more likely to make a mistake with that. Your answer was 2, and that is incorrect. Okay, now we're taking the square root of 225, x to the 5th, y to the 11th. And your answer was 15 x squared y to the, fourth. And then you had the square root of x, y. And so you were almost correct in this, but you weren't correct, so let's cross out that answer. The square root of 225 is 15, so we can pull that out. And a square root has an index of 2. X to the 5th is inside, and to find out how much you can pull out, you take the exponent 5 and divide it by the index 2, and you get 2. So that's what goes outside, and we'll put our radical over here. So what's left after you divide 5 by 2 is 1, so you're left with 1 inside. And you did that one correctly. Y to the 11th, 11 divided by 2 is 5, so we put that out here, and you got 4, and we're left with the y inside. So this is the correct answer. On this problem, you said that there was no answer, so you said the solution set is the null set, but that is not correct. So let's look and see what is correct. To do this problem, you have to square both sides. So on the left, you're left with 17x minus 13. On the right, 4 squared is 16, and the square root of x squared is x. So now we subtract 16x from both sides, and we're left with x, wanted to do that in white, x minus 13 equals 0, and then you add 13 to both sides, and you get that x equals 13. And that is the correct answer. In this problem, your answer was 3, and I don't know how you got it. So let me show you how to do this problem. We're going to distribute the square root of 7. So you have square root of 7 times square root of 7 minus square root of 7 times square root of 13. And then, since they're both the same kind of radical, you can combine the terms, or the factors of each term, inside the radical. So on the left, the square root of 7 is squared is 7, and on the right, 7 times 13 is 91, so we have the square root of 91. And that is as simplified as you can get it. In this problem, your answer is something like n to the 8.25. And you're never going to see something like 8.25. You would not put it in decimal form, but that is not the reason that you got this incorrect. So let's do this problem. We're going to combine our exponents. So that would be 37/6 minus 7/6, and that's going to give us n to the 30 over 6, which 30 divided by 6 is 5. Okay, on this one, your answer was something like 1 over 2 square root of 2, and that's going to be wrong all the time because you cannot have a radical in the denominator. If you do, it is not simplified. So let's look at this problem. We're going to get rid of this. In this case, we need to do something called multiplying by the complex conjugate, or the conjugate. And the conjugate of something is this. If you have a plus b, the conjugate is a minus b. So you have to have a plus in order to do that. Well, not really. You have to have an a that stays the same, and then it's added or subtracted from the a. So in this case, if you consider this a and b, then you have 5 plus square root of 3. The conjugate would be 5 minus square root of 3. So again, here's what you have, and here's the conjugate. So in this case, what we need to do, we're going to put parentheses, is we need to get rid of that radical in the denominator, and we're going to do that by multiplying by its conjugate, top and bottom. So then in the top we have 7 times 5 minus square root of 3, and in the bottom we have that case where you have a plus b times a minus b, and if you remember from an earlier slide, a plus b times a minus b gives you a squared minus b squared. So let me write that again. If you have two conjugates multiplied together, you get a squared minus b squared. So in this case, a is 5 and b is the square root of 3. So you have 5 squared minus, and then you have the square root of 3 squared. So your numerator, we distribute that 7 and we get 35 minus 7 square root of 3. Let me put equal signs. Over 25 minus 3, because the square root of 3 squared is 3. So that's going to give us 35 minus 7 square root of 3 over 22. Now you have to be careful at this point, because if this has a common factor with this and this, then you need to reduce it by the common factor. but in this case it does not, so this is the answer. In this problem, we don't want to have an I in the denominator because it isn't simplified. We have another situation, in this case A minus B, so we know, so it turns out if we multiply 7 minus I times its conjugate 7 plus I, we will get 7 squared minus I squared, and the I squared is negative 1, so the I goes away. So let me do that. So we're going to multiply by the conjugate 7 plus I over 7 plus I. Then on the top we get 50 times 7 plus I, and on the bottom we get a squared minus b squared. A squared is 7, so I'll just write 7 squared minus I squared. So that gives us 50. I'm going to just keep it like this until the very end, 7 plus I over, and then 7 squared is 49, I squared is negative 1, and we know that minus a negative is plus a positive, so then we have 50, 7 plus I over 50, and our 50s cancel, and so we end up with 7 plus I as our answer. Your answer was 7 plus 50I. So it looks like you probably here at this point you multiplied the 50 times 7 and the 50 times I. So here's what I suspect you did. You had 50 times 7 resulting in 350 plus 50I over 50. And you canceled out the 50. 50 goes into 50 one time, and 50 goes into 350 7 times, so that, but you didn't factor out this 50. So when you have a sum in your numerator, this denominator has to factor out in all of the cases. So your answer was 7 plus 50I, and if you had canceled out this 50, because 50 over 50 is 1, you would have gotten the correct answer. Here you have the 2 times the cube root of 375 plus the cube root of 196. 375 is not a perfect cubed, and 196 is not a perfect cubed. So you put that the expression cannot be simplified. But that's not true. What we have to do is to see if there is a perfect cube factor of 375, same for the 196. So you need to write a table at the front of your blue book that looks like this. And you can keep going with this. You can just, 2 cubed is 2 times 2 times 2, which is 8, and so on. When you get to things you don't know, just enter them into the calculator, 6 times 6 times 6, for instance, and you'll get 216. Okay, now let's look at 375. We're going to try to find something that goes into 375 evenly. 216 doesn't, it's too big. 125 does. 125 times 3 is 375. And since 125 is 5 cubed, we found a perfect cube factor. So we can rewrite the 375 as 5 cubed, which is 125 times 3. And then 196, we can see that 125 doesn't go into it, but 64 does go into it. 4 cubed is 64, and 64 goes into 196 3 times. So we can rewrite this term 4 cubed, which is 64 times 3. So now we can pull out the 5 because the cube root of 5 cubed is 5. And we can pull out the 4. And we can see now that we have like terms because the radicals are exactly the same. So for addition and subtraction, if your radicals are the same, you can combine your terms. Let's say that 2 times 5 is 10, and then you have 4. So 10 plus 4 is 14 cube root of 3. And that's the simplification for this problem. In this problem, you were to rationalize the denominator. And you answered that this was this. Well, that is true that it is this, but you haven't rationalized the denominator. Rationalizing the denominator means you get rid of the radical in the denominator. And you do that by multiplying by something that will eliminate that radical. We know that the square root of 7 squared is 7. So if we multiply the square root of 7 times the square root of 7, we get the square root of 7 squared. And that will give us 7, which will eliminate the radical. But we also have to do that with the numerator. So on top, 3 times 7 is 21. And on bottom, the square root of 7 times the square root of 7 is 7. And so that is the answer. On one problem, your answer was 4 square root of m, and the correct answer was 4 cubed root of m. And I think you just forgot to put this cube there. So on the side of your screen, there is one place for using a square root and the other place for using some kind of root, and you can fill in what kind that is. So don't forget to put your index. Okay, here we're going to take the square root of negative numbers. So that means we're going to pull out the negative signs and replace it with an I, like this. That makes that positive, and that makes that positive. So now we have, and let's rewrite it, I times I times the square root of 49, which is 7, and the square root of 64 is 8. Well, I times I is I squared times 7 times 8. So 7 times 8 is 56, and I squared is negative 1, and so that gives us a negative 56 as our answer. Your answer was a positive 56. In this problem, we need to get our square root on one side, so we subtract 7 to isolate our square root. Now, the question is to solve, and when we know that the square root of a number can never be a negative number. It would be perhaps negative 7i, but it wouldn't be negative 7. So since the square root can never end up to be a negative real number, then we know that there is no solution here. So the solution is a null set. So if you end up with anything, the square root of anything equals a negative anything else, you can already know that that is going to be the null set. Here we have the square root of 3x minus 23 equals 1, and it's already set up for us to square both sides. So that gives us 3x minus 23 on the left and 1 on the right. So we add 23 to both sides, and 1 plus 23 is 24. Divide both sides by 3, and we get x equals 8. You ended up with a decimal. And generally, except for word problems, your answers should never be decimals. They should be fractions. And so you need to not rely on your calculator for that. In this problem, you ended up with n to the, and then a decimal over m to some kind of decimal. So that's going to be wrong no matter what. But the decimals you chose also weren't correct. Okay, here, oh, and this problem has a 1/2 out here. Here we want to simplify the denominator first. Or you could have brought down the negative, but you still have to simplify that denominator. So we distribute the 1/2. And so on top we have 7/8 minus n to the negative 7/8. And on the bottom we have m to the 4 to the 1/2 by the power rule says we're going to multiply our exponents. And if you look at m to the 4 times 1/2, 2 goes into 4 2 times, and so this becomes m squared. So this is supposed to be a times. So let's go ahead and bring down this into the 7/8. So we have m to the 7/8, and when we bring it down we get rid of the negative, so we have n to the 7/8, and we still have n to the 1/2 in the denominator, and we have our m squared. So now we need to combine our m's and our n's. So we need to bring either the m to the 7/8 down or the m squared up. It doesn't matter. Eventually it'll work itself out. I'm going to bring m to the 7/8 down. So I have m squared, m to the 7/8, n to the 7/8, n to the 1/2. So that gives me 1 over, and now I combine my m's, 2 plus 7/8, and then the n's become 7/8 plus 1/2. So for my m, I want to make this 2 over 1 plus 7/8, and I need an 8 in my denominator, so I'm going to multiply by 8 over 8. And on the right, the n, I need to have my 1/2 have an 8 denominator, so I'm going to multiply by 4 over 4. So that gives me 1 over m to the 16 over 8 plus 7 over 8 n to the 7/8 plus 4/8, and that's going to give me m 16 plus 7 is 23, and n to the 7 plus 4 is 11. Okay, now I only have one m and one n, and I don't have any negative exponents anywhere, so this is simplified, and that's my answer. Okay, and again, you had decimals and you ended up with an n on top. Now, I'm using different problems than what you had on the test, but your answer on the test was this, and so you don't want your exponents to be decimals. I think you're making some kind of mistake by doing that, so be sure to keep everything in fractions. Okay, you need to know if you have a sixth root in your radicand, and let's start with 2. What is 2 to the 6th power? So we multiply 2 times 2 is 6 times. 2 times 2 times 2 times 2 times 2 times 2. Well, we know 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64, and you can do that in your calculator. So we know we can pull out a 2 because we have a 2 to the 6th in here. Okay, so we pull out that 2, and then we look at our exponents. 12 divided by 6 is 2, so on the outside we have z squared, and there's no remainder, so there's no more z in the radicand. And then we have 24. 24 divided by 6 is 4. So we can pull out that w to the fourth. And now there's nothing left under the radical. So that's our answer. And your answer was 2z squared w to the fourth square root of zw. In this problem, we're told to write the number as a product of a real number and I. And so, and then simplify. So you left out your I in the answer. So let's do this. That's why I want you at the very beginning of the problem to pull your I out, because the square root of a negative is I, and that changes the negative to a positive. And so now all we have to do is find the square root of 192. Well, 192 isn't a perfect square, so you have to find a perfect square that fits into 192, and you need to find the largest perfect square. So if you divide by 2, you're going to have to go for a while. So let's try 4. So 192 divided by 4 is 48. So 4 is a perfect square, and we have 48. But 48 also contains a perfect square. It can be divided by 4, and you get 12, which can also be divided by 4, and then you get 3. So 4 times 4 times 4 times 3 is 192. Now, 4 times 4 is 4 squared, and then we have one perfect square, and then we're left with 4 times 3, which doesn't have a perfect square. So that's going to equal 4i square root of 12. And your answer was 4 square root of 12, which is wrong. That's the end of your review. Make sure you know how to do these problems and take a few practice tests, and let me know when you're ready to retake this.